So I told you people to submit the second assignment, but I don't think anybody has submitted the assignment. I've given the problems which were related to the straight lines concepts, but nobody submitted the assignment to me. Anyway, I'm going to start today's session. This one will take somewhat longer time because it's about the traces. There are certain points that you guys still need to remember. So that's why, without wasting time, let me start the session. Okay. Sorry about that. Yeah. So now we're going to take a problem here. I'm going to choose a different window. The front view, let me increase the font to somewhere around 20. Yeah. The front view of the line EQ is measured as 65 mm and is inclined at 45 degrees to the XY line. The end P being 20 mm above HP, horizontal plane, and 20 mm in front of VP, vertical plane. The vertical trace is 20 mm below horizontal plane. So draw the projections of the line and find its true length and the inclinations with the reference plane. Also locate horizontal trace. So that's the problem that was given to us. So here there is a line here. From the front view, it seems to be of having 65 mm of dimension. We don't know the actual dimension and we don't know the actual angle that this line is making with respect to the horizontal and vertical. But when it is making inclination with both the planes, it seems to be having 65 mm of dimension when we watch it from the front view. And this line is actually seems to be 45 degrees of inclination. I told you in the previous lectures also, the actual inclination of a certain line with respect to horizontal may be 30. Assume that it is 30. Okay, say that there is a straight line and the angle that that straight line is making with respect to the horizontal plane is 30. But when it is making inclination with respect to the vertical plane also, the angle 30 degrees will no longer be applicable. It seems to be more than 30 degrees of inclination when you watch it from the front view. If a line is making inclination with both the planes, the true angles cannot be seen. You will see angles more than that of the angles, the true angles. Okay? And the NP is 20 mm above the horizontal plane. So there is an NP here which is 20 mm above the horizontal plane and 20 mm in front of the vertical plane. Okay, if you want the detailed explanation about these horizontal traces concepts, then you can go to the previous lectures in my channel and then you can just watch every, I think I made around 3 to 4 videos related to the traces concept. Okay, and the vertical trace is 20 mm, sorry, Yeah, vertical trace is 20 mm below the horizontal plane. Okay, the location of one of the endpoints of the straight line is given, okay, which is 20 mm above and 20 mm in front of VP, and the vertical trace is 20 mm below the horizontal plane. So we need to draw the projections of the line and find its true inclination, okay, and find its true length also, and we have to look at the horizontal trace also. But before going into this problem, I just want to recall you some of the important points that you need to remember in case of these traces concept. We will start slowly, no problem. I'm going to take this as a vertical plane. Okay, now see here. So that's the situation that I want to show you. So here, this red colored line is the actual straight line. That's the actual straight line location here. That is how the actual straight line is. If we extend that straight line, it is going to touch the horizontal plane and as well as the vertical plane somewhere, right? So wherever it is going to touch this horizontal plane, we will call it as horizontal trace, and wherever it is going to touch the vertical plane is referred to as the vertical trace. Okay, and if you guys remember properly, I have told you about some points referred to as H and V, right? So what are these H and V? So H and V are nothing but, when you watch them from the front view and top view, you will actually see these traces in the form of just points, right? So see here, if it is a front view, when you watch this line's extinction, so it will just look like, so I'm gonna, let me take a small circle. So that's the question of V when you watch it from the front view. From the front view you can actually see vertical trace, and here it is going to be point H, because that's actually belong to the horizontal trace. So when you watch the horizontal trace from the front view, it will become H. And similarly, let me take the top view as well. I don't think one view is just enough. Yeah, I'm going to take a snapshot of this one as well. Yeah, it's something. Okay, so see here, so wherever it is going to touch the vertical plane, it is actually a vertical trace, but a vertical trace, when you watch it from the top view, it will just look like, wherever it is going to touch this XY line, we will call it as V. Sorry. Okay, so remember these points, and one more thing to be noted here is this is actually the top view. This is the top view of the straight line, right? And here this is the front view of the straight line, right? So the front view H and VT will lie on a same straight line. I'm repeating this again. Front view H and V, all of them will lie on a same straight line. So remember this, and that too, this point V, HT and top view will lie on another same straight line. Okay, so this one is one point to be noted, and this one here is one more point to be noted. Clear? I hope it is clear. So let us jump into the problem. So the problem that was given to us here is the front view of the line PQ measures as 65 mm and is inclined at 45 degrees to the XY line. The NP being 20 mm above HP and 20 mm in front of VP. Let us try to satisfy these first 4 points initially. I'm gonna take a new sheet on the grid off. I have to zoom in as much as possible. Turn the orthogonal mode on. Let's take a dimension 150. Yeah. Now we were given the location of point P. The straight line here is a line PQ. So that's going to be point P dash. Only small letter should be used. And that too, there is the P is actually 20 mm in front of the this vertical plane. So this is just going to be P. Okay. So and we were given the front view of the line PQ measures as 65 mm and is inclined at 45 degrees to the XY line. So draw a line of dimension 65 at 45 degrees of inclination. Okay, that's the, I'm going to mark this one, that's the actual front view. Remember, that's the actual front view. Okay, now, and let's worry about the traces now. I'm gonna give this one a red color. I'm gonna extend this line. So wherever this extension is going to touch the horizontal plane is referred to as, the X1. Wherever this extension of the front view line is going to touch this XY line is referred to as H. Okay, I'm going to call this point as point H. Okay, now what to do? What else we can do? See here, now let's talk about this one. Let's go to the problem once. Wait, I was satisfied there. The vertical trace is 20 mm below the horizontal plane. See here, the vertical trace's location has been given to us, which is 20 mm below the horizontal plane. This point P here is also 20 mm below the horizontal plane. So that's why I have directly taken this line here, taken this end point. Okay. So see here, the front view H and VT will lie on the same straight line, right? So here the front view h and vt, and that too, and we were told that the vt is 20 mm below the horizontal plane. So this is actually locus of vt. Okay, this particular line. So now wherever this extinction is going to touch this one, this is going to be vt, v dot t. Now what else we can do? See here, in order to finish the top view, we need this horizontal trace and the point V. We don't know them yet. If we know any one of them, it could have helped us a lot. And there is one more thing you people need to know here is the H dash is nothing but the front view of the horizontal trace, right? So here what we are going to do here is we will just going to take this line, but we don't know up to at what distance from this line this point exists here. So here the VTs, if you extend this one onto the draw vertical line towards the XY, then you will get point V dash. Well, that's just point V, and that it should be indicated with small letter. Okay, and we know that V, HT and top view will lie on the same straight line. So here this is nothing but the starting one end of the or starting point of the top view. So these three will lie on the same straight line. So what we are going to do is we will going to draw a line like this. So wherever it is going to touch this H dash projection, we will call this one as HT. Extend this line. I want this line to be extended. We'll do one thing, and that too, if you remember, the end points will lie on the same straight line value for the front view and top view. I'm going to draw an extended line, and I'm going to extend this particular line here. That's it. So that's going to be the actual top view. I'm going to draw no line. Give this one a green color. I'm going to trim this. I don't need this one right now. Now, so that's the locus Now what do? We will just going to take this arc here on the same dimension here, and we will going to take the projection in order to get the true length. Take the arc If you are doing this on the drawing sheet, keep one leg of the compass here and another leg of the compass here, and rotate it in such a way that you will actually trying to get the monotone. Yeah, that's it. So now I'm gonna take this line, I'm going to join these two. Similarly, I'm going to do the same here as well. Keep your pencil here on the belong to the compass, and one center here, and then just keeping this P as the center, draw the arc here like this, and then extend it up to that location, then join with P. Now this is going to be Q dash, sorry, what's my, this is going to be Q dash, and this is going to be just Q. That's Q. Now we will name this one as Q1 dash, and this is going to be just Q1. That's it. That's the solution to this problem. Now after finishing the problem, you have to mention the dimensions here as well. So somewhere around 9.95, and this line dimensions here, do not forget to give the dimensions. I'm repeating once again, once you're completed with the problem, give the dimensions. Now let's mention the angles as well. That's the complete solution to this problem. Okay, I hope you guys have understand this concept. I'm moving to the next problem. The next problem here is The line AB of length 58 mm is inclined at 23 degrees to the horizontal plane, and the end A being 30 mm above horizontal plane. See here, there is a line of dimension 58 mm which is actually inclined at 23 degrees to the horizontal plane, and the end A of the line is 30 mm above the horizontal plane. The horizontal trace and the vertical trace are 15 mm and 20 mm below the reference line respectively, and the distance between the projectors of horizontal trace and vertical trace is 30 mm apart, which means the horizontal distance between the horizontal trace and the vertical trace is 30 mm. Draw the projections of the line and find the inclination of the line with the vertical plane. Yeah, so let us, without wasting time, let us try to solve this problem. The end A here is 30 mm above the HP. So draw, that's going to be the point here. Degrees to horizontal plane, and okay, line is 58 mm. 58 mm. We have to draw a line of dimension 58 at 23 degrees, and horizontal trace and vertical trace are 15 and 20 mm below the XY line. So we don't know the locations of the horizontal trace and vertical trace as well. So let us first try to extend this line. How do you actually extend a certain line? If you're trying to use this one, if you're trying to extend this line using a drafter, let us first move this one. We have to keep the drafter position like this. And you have to keep the scale like this and fix the knob here. Once you fix the knob, you can just move this drafter like this, and then you can just draw the lines with the help of pencil, and then you can just draw the line like this. Okay, where until it is going to make the horizontal line or XY line. But here some commands are available to me. I am doing this. Now see here, what we were told about the horizontal trace and vertical trace. And try to move all of these to a certain side so that they can't distract me. We were told that horizontal trace and vertical trace are 15 and 20 mm below. So let us see which one is 15. The horizontal trace is 15 mm below, vertical trace is 20 mm below. This is the locus of HT, or the line on which this horizontal trace exists. Okay, and I'm gonna copy that. And that's the locus of VT. We know that this is actually the true length. That's not the actual front view. So what we need to do here is, first we need to find the So what we have to do here is, first we have to, I think, mark the locations of VH, VT and HT. I'm going to take a small line which one is VT? Yeah, below one is a VT. If I assume that one as V, and if I assume this one as VT, I'm going to delete these two. Okay, I'm going to mark this one as V, and this one as VT. And we were given that the distance between VT and HT as 30. So let us draw a line of dimension 30, and let us draw one more vertical line . I'm going to trim these extended portions here. Okay, I'm going to name this one as that's the location, because HT will lie on this line. I'll call this as HT, and this one as H. H. Now, I think we have determined few things here. I don't need all of this line. I'm gonna trim this portion. Okay, I'm fine with that. Now, we know that V and HT and what else? and the top view will lie on the same straight line. So what I'm going to do is I'm going to have to extend this line. I'm going to try to extend this line. Okay. Now similarly, let us join these two as well. I'm just taking these randomly. Okay. I'm going to take the extend command again. It's perfect. Now, I have to locate this height here, which should be of having 30 mm, which is actually happening here. So on this extension line, 30 mm of height is possible here only. I'm going to delete this one. So that's going to be point A dash. Okay, I'm going to take this one to the top. Okay, this is going to be A dash, and we know that A dash and A will lie on the same vertical line, and that too, what else we know? Let us first take this 53 mm line. So the line dimension, that was true dimension, is 58 mm at 23 degrees of inclination. 58 at 23. So that's going to be the locus. Whatever that I actually needed came here. Okay, so sometimes the problems may be asked like this. So we need to see if this is going to be the actual front view, right? I'm going to name this one anyway. This is going to be the actual front view. So the front view center point and the top view center point will again lie on the same vertical line. So this is going to be the actual top view of the line. I'm going to give this one a green color, and I'm going to give this one red color. This is one of the toughest problems that you can actually face. Now what we can do, we have to take the true dimension from the front view. Center, yeah. Now take this projection. Wait, we need to mark the location of A, right? So that's the location of A. Copy that. This is just here. So we have to mark the location of A here. I don't think, yeah. We can just take this one up to the point. Now It actually lies on the locus. That's it. So I'm gonna erase this additional line so that it will look, we'll be able to see what am I doing here. That's one I need. Don't need any of these. Don't even need this line as well. I can trim this portion also. That's locus line. You can get that. That's also locus. That's it. So let us give the namings. This one is A. This is going to be B dash, and it's going to be just B. This is going to be B1 dash. And this is just going to be B1. Okay, the red colored one is the front view, and this one here is the top view, the green colored one. This is one of the trickiest problem actually. These two are the problems that I want to touch in this particular class. I'm going to repeat them once again, whatever the topics that I've told you today. See here, so the red colored one is actually the straight line. Okay, that's the straight line. So it is having inclination with both the horizontal plane. Okay, this one is actually inclined with respect to the horizontal plane. This is the horizontal plane, and it is inclined to the horizontal plane. And this is the vertical plane, and it is having inclination with respect to the vertical plane as well. So whenever a line is like this, so if you extend a certain line, it is going to touch the horizontal plane and vertical plane at different locations. So wherever it is going to touch this horizontal plane is referred to as horizontal trace, and wherever it is going to touch the vertical plane is referred to as vertical trace. Okay, so when you watch this one from the front view, that is what you see, right? So the HT projection from the front view is referred to as just simply H, and the vertical trace can be seen here like this. The front view, horizontal trace and vertical trace will actually lie on the same straight line. Okay, see here, are they lying on the same straight line or not? See, that's the actual front view, and that's the H, and this is the vertical trace. Okay, H, we use to represent this horizontal trace with respect to the H in the front view. Okay, since we can't see the horizontal trace exactly, how much distance it is from the vertical plane, so that's why we used to represent that one with simply H. Now if you go to the top view, That's the actual top view of the line, right? The top view, HT, and the VT will be represented by small v. Three of them will be on the same straight line. Three of them will be on the same straight line. Okay? So if you compare these two problems here, we have just simply applied these rules here. See, we have this H, VT and front view on the same straight line. Here H, VT and this front view on the same straight line, right? Exist on the same straight line. And similarly, here this top view, HT and V will lie on the another straight line. V, HT and the top view. We are just using these rules in order to achieve what we want to achieve. Similarly, in this case also, V, HT and top view are lying on the same straight line, and front view, H and VT are lying on the same straight line. Clear? I hope it is clear. But before that, let me give the dimensions. $15. 37.10. That's the distance of point A from the vertical plane. If once you became good at these concepts, understanding these concepts, you need not to open your textbooks as well. That's true length. Oh wait, and that's the true length. We should get 58 right. Let me try to project this one. To 0. So 9 dimension here. 58. That one is 58. So here the true dimension should also become 58. Somewhere I think there is a small mistake. That's the front view. The same dimension has been projected here. Where was the wrong? Where am I wrong? Wait up here guys, I think I might have done something very small mistake. I have to take this dimension onto the base projection. I have to take the arc here. Wait, I just want to delete all of this. That's okay. That one is fine, because that's the extinction from this one, and this is actually the true dimension 58. Now this one is 58. That is fine. At 23 degrees of angle, it should be. This one is also fine. How long did I actually take that? Take this projection up to this one, and I have to take this curve. Since I don't know the locus of this one, I'm gonna lay this one like this. This one has to be the actual top view. Now wherever this line is going to intersect, so we have to extend this one. That's not should be the actual front view. I'm having some over constraints here. This VTH are on the same line here. X2 should be at 20 and 15. 20 and 15, that is fine. How can that be? Let me see the problem. Horizontal trace is 15. Wait guys. And the vertical trace is 20. This one is 15 and this one is 20. I think the problem is with these. I think this one should be VT and this one should be HT. This one should be VT and this one should be HT. VT should be 15 mm. This is what should be the VT. I think we have to solve this problem once again. Because see here, I'll tell you the situation. VT, H and front view should lie on the same straight line, right? So I have taken this line and this is the true dimension. So wherever this endpoint is there, so that's the locus of B. The B dash, B1 dash will lie on the same straight line. But if I was to do so, okay, if I have to follow this one, if I was to follow this line here, if I sorry for that, yeah, if I just taken this line, this is going to be the top view, right? Now if I take the locus here, see what happens. So wherever this 58 mm line, set this to 58. I'm telling you the actual problem. I think the problem, there is a mistake in the problem. So that's the projection. Now if I try to take the arc, it is trying to give different location of the front view. See, that's the problem. From this geometry's perspective, that's the actual front view. But whereas we need this front view and H and VT to be on the same straight line. But these are the actual dimensions. I hope you guys might have understand what am I trying to say here. I'm gonna erase this one again and I'll show you. See, the main thumb rules are the front view, H and VT should be on the same straight line. I think doing this problem wrong can explain you so many things. So this front view, H and VT should be on the same straight line. That is the first constraint. And what is the second constraint? The front view's endpoint and the top view's endpoint should be on the same vertical line. But whereas if I am when you solve the problem perfectly, each and every rule will be satisfied. But here I'm not able to satisfy few of the rules. That's because there is a mistake in the problem. From this inclination, okay, from this one I have taken this top view. This is actually the top view. So if I take a line here, nothing is happening. No. Okay. If I take this line here, if I take a locus of the line here, okay, and if I try to measure the true line dimension will not change, right? This true dimension is 58. So here also if I take a 58 mm arc and if I try to project the front view, these two dimensions are not getting equal. So that's because there is a mistake in the problem. We have followed exactly what was told in the problem. HT is 15 mm and VT is 20 mm below the horizontal plane. But I think it is the reverse case. VT is 15 mm and HT should be 20 mm. See here, when I draw the actual front view, I am actually getting slight inclination here, which means the VT has to be somewhat upwards. So I'm going to try to draw this one again. First I'm going to start with these lines VT and HT. So one is 20 and the one is 15. So previously we have taken 15 for the HT and 20 for the VT, but whereas we will going to change this. There is definitely a mistake in the problem. We have followed each and everything properly. Let us try to change. Now I'm going to take this point as V. So this is going to be V dash, sorry, VT. I'm going to name this one. this one as VT. Okay, so the distance between these two should be 30 mm. Now from the midpoint I'm going to take a line of dimension 30 and I'm going to call this one as H. This one is going to be H. Now you can delete this line. I'm going to take the straight line now. So at the end I'm going to take a reference line because I need to extend this one up to this line. You guys don't need to draw this line. You can just take your drafter and fix the scale, fix the knob, and then you can just draw the lines. So VT and H and front view will be on the one straight line, VHT and the top view will be on the same straight line. So I'm gonna try to extend this line, extend. Not getting extended. Yeah. Okay, that's fine now. Now what I need to do, I have to look for a height of 30 because point A is 30 mm above the HP. So that's the point that I'm actually looking for. I'm going to delete these two, I don't need them. And similarly the point A will also lie here. A dash, that's going to be A. Now we know that somewhere on this line we can measure the front view, but whereas first we need to talk about the actual true dimension. The true dimension here is 58 at 23, 58 at 23. So that's the locus. And similarly from this point, we don't know the angle. So that's going to be the front view. Let us try to take the, wait, am I taking the intersection point? Yes, I'm taking the intersection point. It's fine. That's going to be the top view. Okay. Now let me draw the locus lines here. I just want to make sure that these two are okay. think I've made a small error, so that's why I'm getting this. This one is true, this one is fine. So this is the actual top view. I can keep this. So these two are in reverse order. This one is 15 and this one is 20. So here I can just take the locus here, and I have to take the arc command, make an arc of 58. Right, what am I doing? I think it's a straight line. I think I made a small mistake. Okay. That's it. Let me define top view and front view as well. If I take the projection to this particular location, this one should also be approximately equal. Yeah, approximately equal. I think I made maybe a small error here, so that's the reason why. But this is the actual solution. Okay, I'm getting the front view and top view as well. So let me delete these additional portions. I don't want this. I can delete this line. That's the top view. That's the front view. These two are true dimensions, true lengths. The red colored one is the actual front view. You just want to take the projection, you can take the projection here vertically, and you can just take the arc. But that one is fine. I'm going to just take the dimensions, but before that let me mark the top view as well. This one should be 15, yeah, 15. Okay, this one has to be 20. We have to find the distance and the distance. T8. We'll have to measure these heights also. How much distance it is actually. That one is 40. This one is 30. No, I think it has to be measured from this location. See, most of the times they are getting snapped to these texts here, so that's why you are getting these small errors. Okay, when you do it with yourself, with your drafter, and there won't be much of a problem, I guess. Still it is snapped to something else. Okay, it should be 60. Has to be 60. Okay, so let us measure the angles as well. This 7, that's correct. And submit the second assignment by today evening without fail. If you guys fail, I'm gonna give 0 marks to all of you. See, even if the exams were cancelled to you, think at once. If you guys don't have the assignment marks, then how will you get pass marks? How will you get grades? You won't get credits. That's for sure. Then entire marks will be in my hand only. If your exams are cancelled, entire marks will be in my hand. You understand that? And without evidence, I'm not going to provide marks to you. Remember that. I hope you guys will do that by today evening. It's all up to you. If you guys want marks, then just submit it. Submit the assignments. If nobody submits, it means I'm going to put 0. I'm not going to give any marks to anyone. It's all up to you.